Hey guys, it's your boy. No, I'm just kidding. Hey guys, it's Basina. So today we're gonna go ahead and learn how to model functions, applications using sine, cosine, and tangent. So go ahead and pause the video real quick and then we'll start on this warm-up. I want you to go ahead and label the adjacent side given that angle, the opposite, the hypotenuse, and start thinking how can we find the height given this information. So go ahead and pause the video and give that a try. Okay, so hopefully you were able to see that we have, where's my mouse? That we have right here is 30 degrees. This right here will be my theta. And we have the following values. We have the following values of this 10, which is my adjacent. Sorry about that. We have the adjacent. We have this h right here. This will be our opposite. And we have the side right here. This will be the hypotenuse. Okay. We can also find the remaining angles, which this right here is our 90 degrees, right? Assuming the floor is horizontal and the tree is completely vertical. And we have this right here. Keep in mind the entire triangle is 180 degrees, so we have 60 remaining. So that will be the angle for that. Missing the missing angle. Okay, so from here, guys, what we're gonna go ahead and do is we're gonna go ahead and find out what trig function can we use given that we have an angle theta, we have a length for my adjacent, and we have a length for my height, which is our opposite. So we know sine, we know cosine, and we know tangent. Okay, we know all of these, but only one of these functions will be the easiest to do without having to find additional information. So I know later on in your math career, you'll learn how to do law of sines, law of cosines, and different proportions that will let you find these angles. But given only what we know from this picture, we can go ahead and see that we have theta, adjacent, and opposite. So we should have everything needed for doing this using tangent. Assuming that we're using tangent of 30 degrees is equal to my opposite, which is my h, and my adjacent, which is my 10 feet. From there, we can go ahead and solve for h, and then evaluate, and we can find out the height of this tree. All right, so that's what we're going to go ahead and learn today. Keep in mind, this is a week at a glance for my students learning with me at school. Today, we're going to learn how to do evaluate these applications using sine, cosine, and tangent. Okay, so what I want you guys to do right now is to go ahead and pause the video and practice labeling these adjacent sides, these opposite sides, and these hypotenuse sides of these triangles, given that one theta will be in the horizontal and one theta will be right on top in the vertical. Okay, so hopefully you were able to do that. If you need more time, go ahead and pause the video. So if our theta is right here, we can see that this right here is going to be my adjacent. Keep in mind, this is the one that's close to the horizontal. And we have this length right here is the opposite. And we have the hypotenuse will be created with our right angle. Okay. So these right here will be only for right angle trigonometry, but we will eventually learn how to do it with different angles as well. Okay. So this one's not too hard. This one's pretty much like a quadrant one. This is not that bad. It gets a little messy when we have this right here, when we have our angle at the top. So ideally, students go ahead and say, oh, this one's a horizontal, this one's my adjacent. But keep in mind, that does not work when we have our angle on top. Now, this is the opposite. This becomes my adjacent, right? Because this is the one next to it. And my hypotenuse always stays the same. It's always the longest length. Okay, now there's two takeaways that I want you to go ahead and see. This right here is the angle of elevation. Okay, meaning that from this point, you went ahead and saw it all the way to the tip of some building, the tip of some tower, or something like that. So your sight, you're looking at it from this, something like that. You're looking at it from the bottom up. Okay, how does that change for angle of depression? Okay, so now it's the same thing. You're gonna go ahead and see it that you're looking at a point on the ground. Okay, so pretty much you're sitting on your bed and you're looking down on the floor or something like that. Okay, and then versus your in versus angle of elevation, where you're just looking up to see the ceiling. Okay. All right. So something that my students catch me saying a lot is in quadrant one, I'm like 0 to 90 real quick, but in reality, it's 0 to 100 minus 10 degrees real quick, right? So hopefully that helps in remembering it. Okay, so what I want you to do is go ahead and read this question and sketch out a little diagram that would go ahead and make this possible. So go ahead and pause the video, give this a try. So I had a lot of students draw some very nice things. Unfortunately, I'm not as artistic, but I'm gonna go ahead and try my best. So we have a wire that is tied to the top of a tower that forms 75 degrees. So I want you to pause right there. Is that an angle of depression or an angle of elevation? So if it's from the ground all the way to the top, this 75 is the angle of elevation. So we're going to go ahead and draw the ground the best way we can, right? And then there's going to be some sort of tower, okay? Right, something like that, some tower. And in that tower, we have that we tie a string or a wire to this tower. This is the top, right? So we have something like our right triangle right here. And that the angle that is formed at the horizontal, at the ground, to our to up of our tower is 75 degrees. Now the distance from this point to the base of this tower is 55 feet. Can we go ahead and find out what is the height h of this tower? So go ahead and start deciding what are my adjacents, what are my opposites, what are my hypotenuse, and what function can I use? Can I use sine? Can I use cosine? Or can I use tangent, given that I have the following information? So go ahead and pause it right there. Okay, so we have this. We have an adjacent side because my angle is right here at the bottom, the angle of elevation. We have an opposite, but I do not have my hypotenuse. So therefore, I cannot use sine and I cannot use cosine because the length of the wire is unknown. The hypotenuse is unknown. So we have tangent of 75 degrees is equal to my opposite, which is my height that I don't know of, and my adjacent, which is 55. All I'm going to go ahead and do is solve for h by multiplying by 55 on both sides. And I have 55 times tangent of 75 is equal to h. If we go ahead and approximate, I got that my answer should be 205.27 feet for my solution of this height of this building. Not building, but transmission tower. Okay. Let's go ahead and try the next one. So let's go ahead and try the next one. We have a point that is 340 from the building. It has an angle of elevation of 65 degrees to the top of the building. What is the height of the building? So go ahead and pause and draw me that scenario. Okay. So we have very, very similar because sometimes the hardest part is learning how to draw it. So we have the building, right? And again, guys, I'm not the best drawer. You can clearly tell from that horizontal line, totally horizontal. So the top of the building, right? Okay, and we have something like this. We have an angle of elevation. Let me go ahead and do that in red. From here to here, that I can go ahead and see that the angle with the horizontal ground to the top of the building is 65. And with the distance from the bottom of the building to that point is 340. So this one right here is very, very similar because they want us to find the height. So we can go ahead and see that my adjacent is still right here. My opposite is still the missing length of the height, and my hypotenuse will remain the same. So given that we only have the angle, we only have the adjacent, and we only have the opposite, we're left to only use tangent of 65 degrees is equal to the proportion of the height, which is the opposite length, over the adjacent side, was 340 feet. And from here, we just go ahead and multiply 340 feet because we're solving for h. Tangent of 65 is equal to h. Okay, something like that. Can't draw an h. I'm just going to do capital R. Okay, so with the magic of our calculator, we can go ahead and see that this is going to be 729 and 13 feet. Okay, so very, very similar to what we just did. This is just to get a feel for the right triangle work. All right, this one's going to be a little bit more challenging, but I'm going to go ahead and give you some context since when I typed this question out, it was a little bit funny. So pretty much you have the shore, let's say the beach, and then away from that beach, you have a little island that is 350 feet from the little side of the beach, from the shore. And we're going to go ahead and assume that the lighthouse is making some sort of distance with the angle x. Okay, so let's go ahead and pause right there and draw that. So I'll draw it here too. And we have something like, and believe me or not, my students did way better in this one than me. So we have here. So I'm going to go ahead and say this is my sandy beach, super sandy, something like that. Okay. Then we have a little island right here. Let's go ahead and do that right there. That little island has a lighthouse. So let me go ahead and say the lighthouse is from the top view. Right? It's from the top view. We have something like, I don't know. Okay, something like that, right? That's me trying to do 3D shapes. Okay, so we have something like a lighthouse like that. And this lighthouse is 350 feet from the shore. So from here to here, keep in mind, guys, you have complete control over this drawing. So you can always say that from here to here is going to be a horizontal line. Now, this lighthouse is going to go ahead and project its light to a certain point. We don't know, but we do know that that angle that is being projected, the angle is told to us that it's angle x degrees. Okay. Now they want us to go ahead and find the distance d of this function for the distance that where the light traveled. Oops. Okay, so what we're going to go ahead and do is express this as a function. Given that we don't know the angle x and we don't know the distance, but we know the distance depending on the angle x. Okay, because the lighthouse is just doing its thing, right? So we're going to go ahead and do the following. We're going to go ahead and see that, hey, I have this angle right here. So therefore this right here is my height, right? Because this right here is a perpendicular. It makes a right angle with the horizontal beach, the shore. And this right here, the 350 feet of distance. So this right here is my adjacent. This right here will be my opposite. And this D will be my distance. Okay. So the only option that I have, given that I only know my theta, I only know my adjacent, and I only know my height, my hypotenuse, I can only use cosine in this scenario. So cosine of my x value, my angle that I don't know, is equal to the proportion of the hypotenuse, which is d, over my, not the hypotenuse, what am I talking about? The adjacent, which is 350, over the hypotenuse d. Okay. Now, they want us to express it as a function. Sure, this works, but I'm going to go ahead and set it as d equals. So I'm going to go ahead and solve for d. So d is equal to, well, all I have to do is multiply by d on both sides. Where is my pen? Okay, so this is going to take a little bit of work. So I'm going to multiply by d on both sides. So now I have d, oops, now I have d cosine x is equal to 350 feet. From here, all I have to do is get rid of cosine x divided by cosine x. D is equal to 350 feet divided by cosine x. Awesome. Okay. Now this is going to be useful in the sense of being able to calculate the distance at the given time. Now this is not the only way to write this. We know that when we have 1 over cosine of x, that's the same thing as saying secant of x. So this can easily be said as 350 times secant x. Don't forget the units. So keep that in mind. Okay. All right, last but not least, I have this example. So go ahead and pause the video and draw that scenario. Okay, so hopefully you were able to get something like this, where this person is looking through what's called a telescope to some distance at a tree. Keep in mind that the telescope in the real world is not on the ground. It's actually lifted a little. So the tripod is 5 feet. And she's able to measure the height of this tree, but keep in mind that it also accounts for the 5 feet of the telescope. So make sure you add that in. So according to this, we have our theta, we have our adjacent, and we want to find the height. Okay, so very, very similar to what we've been doing. So we have tangent of 8 degrees is equal to my height, right? My tangent is opposite over adjacent, so my height divided by my adjacent, which is 120. Okay. From here, we're not done because we still need to go ahead and add that 5 feet. So it's going to go ahead and do the following. So we're going to go ahead and solve for h by multiplying by 120 on both sides. So we have 120 times our tangent of 8 is equal to h. Now keep in mind that 5 feet, we still need to add it. So it's going to be 120 times tangent of 8 degrees plus 5 feet is equal to my h. And I believe I have the answer for that one too. I got that it was 100, no, not 100, whoa, 21, 86 feet. Okay. So hopefully these were a little bit easy, or at least some sort of approach to them. Other than that, is the main idea is going ahead and sketching it out. Okay, we will go ahead and go to other examples where it is not a right triangle, but that will be later into the unit. Okay, other than that, that's all that I have for you. I did go ahead and make 3 more examples of these practice problems, and where I asked them more questions, and I have a bonus one to see where we are in terms of the higher rigor. Okay, other than that, guys, it was a pleasure, and thank you. I'll see you guys in the next time. Bye-bye.